Hello. Hi, everyone. Welcome to United Astronomy Clubs of New Jersey. We're back on site in Jenny Jump State Park in Hope, New Jersey. While people are still filing down from parking and whatnot, I want to uh, have everyone give everyone a big welcome here. Also, a couple of reminders. Do check us out on our website, uacnj.org. That's where you're going to find all of our information on current talks, past talks, all sorts of information on who, our member clubs and who we are as an organization. And it's also where you're going to find a link to all our fun social media pages and YouTube because we do live stream this on actually YouTube and Twitch. So if you ever, feeling under the weather, looking for something to do on a Saturday night, you could always, and you can't make it here, you can always join us online. That being said, like I said, we do have social media pages. So follow us on Facebook, Instagram, Twitter. We'd love to see you there asking questions as well as in our Discord channel. And I forgot my last bit of thought. Sorry, I haven't had quite enough caffeine today. I'm sure we've all had feelings like that, especially since the trees are pollinating, since it's no longer raining constantly. And we can see the sky. But with that, for those of you who are here, a couple safety things. When we go to leave, we are going to use our headlights. Yes, even though they're bright and annoying, we like not being run over, and I'm sure you also agree with that sentiment. If you need to use the bathroom, it is the porta potty off to all the way in the back of the tent, off to my left, your right. We also have a little museum and gift shop area that I'll be manning after the presentation that you can also check out. In addition, each of those little sheds with the roll-off roofs, that's where we house all our telescopes. So after the talk, we will have people, our volunteers out there, and they'll show you what's available in the sky, although tonight's a full moon, so the moon is a very bright object and sometimes crowds out the other dimmer objects. That being said, tonight's presentation is What's Up in the May Sky, normally given by Lonnie. Unfortunately, he could not make it here today because of unforeseen circumstances. So we have his body double, Paul. Paul Fischer has a Bachelor of Engineering in Chemical Engineering from Stevens Institute of Technology and has worked in the environmental and chemical industries. Though always interested in celestial objects, Paul's official start in amateur astronomy was one night several years ago, lying in an awkward position on his roof in the freezing cold, holding a pair of binoculars. He caught a brief, clear glimpse of the Galilean moons of Jupiter and was hooked. And after some introductory reading, he purchased his first telescope. He's now an active member of many local astronomy clubs and volunteers and is current president at United Astronomy Clubs of New Jersey. He still frequently managed to find himself outside at night in the freezing cold or the sweltering heat, depending on what season it is, still gazing up at the night sky. And with that, Paul.
Hello, everybody. Thank you. And thank you, Kim. And so we're going to start out. First of all, I am not Lonnie's body double at all. Sorry for the insult, Lonnie. What's up in the May sky? Lots of Mayflowers there. And Lonnie always includes references. So that's where he got that picture from. And this is us. And goastronomy.com. Lonnie pulls his main schedule off of this website, if I remember correctly. So this is another place that you can go if you like some of the information you're seeing tonight. And I would like to just one other thing about Lonnie not being here tonight. Lonnie did prepare a lot of these slides. I prepared some of them. And so I want to just warn you that all the good stuff that happens in this presentation, you can credit Lonnie. And if there's any misinformation or bad information, you can blame me. So just want to put that caveat in there. This is some of the things we're going to talk about tonight. What's up in the May sky? First of all, tonight we are going to be dominated by the full moon. The full moon is very bright. You can walk out, you all know, walking out in a full moon. It's almost sometimes like daylight. You can navigate around so well. Unfortunately, that does bad things for being able to see things in the sky. And I'm walking out of camera range, so I'm going to walk back. Sorry. Secondly, just so we're aware, we're going to talk a lot about the moon and what's available. Just because the moon is available and other things are not doesn't mean there aren't interesting things to look at. So we will talk about the cool things we can look on the moon. Then there's the penumbral lunar eclipse, which we will talk about in theory. Unfortunately, the people who can see that are on the other side of the planet, so we won't be looking at that tonight. The Eta Aquariid meteor shower peaks or peaked this morning. Still pretty good today, but again, we talked about the full moon. So I would look up during the night here to see whether you see any shooting stars. That's a good idea, but I wouldn't anticipate seeing a whole heck of a lot or maybe any because of the full moon. But you can get some really bright ones, fireballs, that type of stuff. So keep an eye on the sky, not just in the telescopes while you're here. We'll talk about the new moon phase, and then we'll talk about Mercury, and then we'll talk about some other objects you can see tonight. All right, so here, can you see this pink region live audience? Yes, no? Okay, this pink region are all the people that can see the penumbral eclipse. As you can see, we're over here or here, so we're not in that region, so we're not going to be able to see it. The people outside here in this darker pink region here can see some of the eclipse, but not the entire part. So we're just out of luck. Europe, Africa can see part of it. Asia and Australia can see the whole thing, and we don't get nothing. What is a penumbral eclipse? Why is this different from a regular moon eclipse? Well, here is the umbral region, and here is the penumbral region. So this inner circle, most of which is up off of the page, and is the umbral, and this part is the penumbral. And what does that mean? Well, the next this is as if we're sitting here on Earth, which we are, and looking up at the moon normally. This one is looking it from the side where we're out in a spaceship away from Earth, and it might make more sense in this direction. Here is the umbral section. Here is the penumbral section on the outer, so this would be the outer big circle from here all the way down to here. And then this is the inner part of the circle, like the donut hole you would cut out. Okay? This is the umbral section. This is the penumbral section. And then this whole part here just sees sun. Right? Because the sun's so bright, it would make the moon disappear. Now, why is that happening? And these lines of shadow or light on this side, shadow on this side, illustrate why it's happening. It's happening because the sun is not a point source of light. If the sun was just this dot, then there would only be one shadow. But what's happening is that even some of the light here can just bypass Earth and travel this direction. Oops, sorry. And becomes part of the penumbral region instead of the umbral region. So here is where the light is totally blocked out. All of the sun is blocked, here partial amounts of the sun are blocked. Does everyone see that? Cool. All right, so tonight is not the full moon. The full moon was yesterday at around 1:34. Here we are. So it was yesterday at 2:23. Yesterday, May 5th, 2:23 at 1:34 p.m. Technically, tonight's moon is a waning gibbous moon. It rises tonight at 9:32 and sets at 6:13 in the morning. And it is a minus 12.47 magnitude, which is really small, correct? No, magnitude's a little bit of a trick. Magnitude is a measurement of how bright something appears in the sky, and the smaller the number is, the brighter it is. So a negative number is very bright. It is 98% illuminated tonight. The size of the moon, the apparent size of the moon, is 31 3/4 arc minutes. If you remember how many minutes are in a degree from way back in math, that's about a half of a degree right there. Its actual size is, the diameter is about 2,159 miles. That doesn't change, so that number will be the same all the time. And then finally, the distance from us is about 234,034 miles. That does change because the orbit is elliptical. It's not a perfect circle. And interestingly, this unit here is called an AU, an astronomical unit. It's 0.002518. And what does that mean? Well, an AU is the distance from the sun to the Earth. So that is the ratio, that it is 0.2% to 0.25% of the distance from the Earth to the sun is the distance to the moon. All right, so what can we see on the full moon? I took this picture up here, and I'm no expert. There are people tonight we'll have somebody at one of the observatories in that direction who will have EAA running. So he will be showing you live pictures of what he's seeing in the sky, and you'll be able to see in some of the directly in a lot of the other telescopes here. So a lot to look at tonight, but you'll get a chance to see electronic pictures that are hopefully better than the ones that I took here. So what can we see on the moon tonight? Maybe in EAA, but certainly here. And you'll see them in the telescope even. You'll see seas and craters and rays. No one? Oh my. All right. So the seas from counterclockwise from the top, the Sea of Crises, the Sea of Fertility, the Sea of Tranquility is this big one here, the Sea of Serenity, and this one here is the Sea of Cold. And north is this direction in this picture, on this side. What else can we see? We can see craters. And the two that we can see very easily on this photograph is, let me get the Langrenus, which is this guy right here. And you can see this one, which is smaller, is Proclus. And Proclus has some interesting features. See these white lines coming out from the crater? What do you think the crater was created by? A meteor. So when it hit, you can see almost the spray pattern of what's called ejecta coming out of the crater. So it dug all that rock and regolith, it's not soil on the moon, it's regolith, out onto the moon, and then through it, you can see it across the moon. See how it's you can see it in high contrast against the Sea of Crises, and you can see them go right across. There is a moon in the a crater in the north called Tycho that's out of this picture up around that region that has ejecta going, 3/4, halfway across the moon. So pretty. You can just imagine the impact that's throwing ejecta 1,000 miles across the moon. And that's what these rays are. So you see these white lines coming out of craters. That is the rays. And the full moon is excellent for seeing those rays. And the craters and the seas. But definitely check out the rays. All right, and Lonnie wanted to always identifies the moons. I think this is just a reminder that how old astronomy is and how culturally relevant amateur astronomy is. All right, because we have some names, Indian names of this moon, the green grass moon, the root food moon, and names from the Farmer's Almanac, the milk moon, flower moon, corn planting moon, grass moon, mother's moon. So these moon names are not written in stone, and there is no one official name. You should realize that it is it depends upon the tradition, and certainly in antiquity, these moons are important to the society that where you get the name from. Here's a schedule. Full was on Friday. The last quarter will be on the 12th, and you notice here that it's a half, right? So a quarter moon will look like a half a moon in the sky. It's half of the cycle, not half of the moon. That's why it's a quarter of the cycle, not a quarter of the moon. So that's where the name difference comes from. So it's the last quarter of the cycle is 1/2 of the moon. Then we come to the new moon. Then the other half of the moon comes up on the first quarter of the cycle. And that's on the 27th. That's better illustrated maybe, or more largely illustrated on this slide. And so a lot of people really are impressed with the lunar terminator and what you can see here, which we'll talk about in a second. I just wanted to make sure that we talked about the full moon, that there are things that you can see on the full moon that are difficult to see on a quarter moon, but there's also cool things to see on the quarter moon or a partial moon that you can't see on the full moon. And right here along this terminator, what do you see right next on the light side? What do you see right next to the terminator there? Anyone? Craters. You see the larger shadows, the deeper shadows of those craters. So you get to see a lot more of the terrain of the moon when you look at the lunar terminator. So anytime you're looking at the moon in, say, a telescope or binoculars, and it is a gibbous, a waning gibbous or crescent phase of the moon, then you take a look at the terminator specifically to appreciate the terrain. Lonnie makes a point that sometimes not sometimes, often, you don't need a telescope to appreciate astronomy objects. So all these the relatively cheap. I mean, there are things here that are $9. There are things here that are $30. All these relatively cheap optical binoculars or monoculars. It's it's not monoculars, monocular. All these relatively cheap optical equipment you can use to appreciate some astronomy objects, and specifically the moon. All right, so we talked about the full moon phase and the penumbral lunar eclipse. So the next thing on the next topic we're going to talk about is the Eta Aquariid meteor shower. And just we're going to watch this one at least twice. So that's the Earth, and this is Halley's Comet. So the source of this meteor shower is the Halley's Comet. The peak is this morning, and you can still see them. That's just the peak. You can see them on either side of the peak too, from April 19th to about May 28th. And the hourly rate is about 55. It's not a very active shower, is what that's saying. And you can see the path that Halley took through Earth's orbit. The lines up here are saying that Halley's Comet is underneath. Now it's saying it's over. And back down, and right here, May 5th. And so that's what's happening. We are going around the sun, and then May 5th comes around right in here. That's May 5th on that portion of the orbit, and that's what's happening, is we're going through that trail of stuff left over from the comet. That's kind of a cool animation. Thank you, Lonnie. Wrong direction, maybe? Just a bad slide. All right, so Lonnie likes to use this program here. This program is a navigation or a star chart, an online star chart. This particular one's called Stellarium. Lonnie's very good at manipulating it live for an audience. I'm not, so you're going to see a bunch of stills. And right here is the Eta Aquariid radiant of this particular shower. This radiant is right here. That's the Eta Aquariids. What is Eta Aquariid? Well, it means that the radiant is located in Aquarius, and Eta is one of the stars, starting with the stars get labeled alpha, beta, gamma, etc., etc. And so it's one of the stars in the constellation Aquarius. And here's the date from the Stellarium, which looks a lot like our date. Now, I helped you visualize it a little bit better, because Stellarium doesn't do a great job of visualizing what a radiant is. So here we're looking down the barrel of the confetti cannon, like a confetti cannon you would see in a circus. So we're looking down. Halley's came from there straight out this way. And so we're looking down the barrel of where all that stuff is coming from, right at us. And that's what the radiant of the meteor shower is. And so the meteors would follow. They don't necessarily have to start right at the radiant. They could come halfway across and then disappear a little bit later. But they would follow any one of these infinite paths coming out from the radiant. So that's what the radiant is. So that's where you can look sort of to expect to see them coming from. And this happens to be tonight at, or tomorrow morning at 4:45 a.m. The best time, unfortunately, to look at most showers is when we're staring right down that barrel, and that tends to happen in the wee hours of the morning. So the last thing on the Lonnie's hit parade here is, let me make sure I'm hitting the right button here, is the Mercury at greatest elongation. Now this happens before the sun comes up. This is looking in the east. The sun's down here. Let's let me make sure I'm have my directions correct. That's the east, so south is going to be that way. So maybe the sun's down over here, and then Mercury is right there coming up before the sun. And so Mercury is always going to be relatively close to the sun because in our sky, because Mercury is close to the sun and never gets far enough away from it as it orbits the sun for us to have an appreciable distance in the sky between Mercury and the sun. In fact, if you're pointing a telescope at it, you have to make sure that you are pointing a telescope at Mercury and you can't bump it and hit the sun by mistake, because that would do bad things to your vision. So it's actually a little bit of a safety issue to be looking at Mercury through a telescope, or at least you want to be careful. We won't be seeing Mercury tonight because we would have to be up right before dawn in order to see it. So what can we see? What other things can we see in the May sky besides those events that we've already mentioned? Again, Stellarium is the program that Lonnie likes to use to illustrate all those things. So you'll see a lot of the Stellarium references here in the next coming bit. However, I want to say that Stellarium isn't the only thing, and you should never settle on just one application to guide what you want to see in the sky, because they do different things and they have their strengths and challenges, each one. Stellarium's great. I wouldn't suggest that you want to say, I want to sit down and find something to look at the sky tonight. Let me just start Stellarium and start and jump right in there. That's not. It's too specific and too. You'll find one or two, or maybe 3 or 4, but you won't get an appreciation for the entire sky because it zooms in on a specific place, and then you can see some of the objects in that place. But then you actually have to start manually going around looking at different parts of the sky in Stellarium. So other objects, aids will help you maybe get a more general understanding of what's up in the sky. And if you saw maybe my talk 2 weeks ago, I talk about, say, a planisphere, and I talk about a star atlas as general references that you could use. Well, this is another one if you don't want to go completely paper like a planisphere or an atlas. This is an online map, an evening sky map. It's specific for May. So this is showing you what's up in the May sky. And you can see all the constellations here. And you can't see them in the audience right now because it's too small. But there are various symbols in between the constellations showing what's up in various places in the sky. So you'll have to take a look at that online at home later in order to actually appreciate that. However, I want to point out this other feature on the second page of this PDF is that they, in many atlases and in the sky map, and other online references, they have these lists of objects that you can see in the sky, in that portion of the sky, or during that month. And so here on this side are easily seen objects with the naked eye. Here are easily seen objects with binoculars. And then finally, the last one is telescopic objects. And they are, right here is a catalog number. It's a Messier number or an NGC number if you're familiar with that. Right here it tells you what constellation it's in. It tells you this is a symbol right here for what type of object is, and obviously a description. So this is more of a general overview and is very useful if you're trying to find things to look in the sky at night. So don't just use stellarium. There are other things to use also. And Lonnie does, of course, make a point of pointing out that there are many references you could use. These are all online references here. Skyview, Google Sky Map, what else is there? Skywalk. There's a NASA, of course. There are a bunch of others that you can use. All right, so what's going to be actually up tonight? Well, Venus and Mars, first of all. And here we are at the correct date. And this is about 10 o'clock, like the sky map I just showed you was set for 10 o'clock. And right here is Venus, this really bright one. And right here is Mars, this dimmer one. And there's an arc that's along here. Does anyone know the name of that arc that Venus and Mars is lying on? The sun and the moon happen to be on that arc, and so does all the other planets. Does anyone know the name of that arc? It's the ecliptic plane. So if you know where the sun and the moon go, you know that they travel around the same position in the sky every night. All of our solar system happens to be planar. In other words, it's all in the same plane, so they all fall along that arc. So if you see a bright object that looks like a star, but it happens to be in the same place that the sun and the moon go, it's probably a planet. And that's what's happening right here with Venus and Mars. Again, this is stellarium. And you can dial in, like I said, today's date and 10 o'clock tonight. All right, and this is actually me up here knocking the dust off after a winter. I don't like to go out during the winter because I'm a wimp. But there are plenty of astrophotographers and other amateur astronomers who do come up during the winter. I did not come up this winter, and but so I was knocking the dust off a little bit. I didn't update my program. However, this is M102, so this was actually an object I took a week and a half ago. So that's a quick screenshot. This one's really interesting. It has a dark, it's a galaxy, and it has a dark dust lane right in front of the galaxy. So kind of cool. You can't see that right, the dark lane, unless you get right up on top of it. But it's there, and again, we have EAA tonight, so maybe we can see some galaxies with some interesting features tonight. And right here is where it's located. And let's see, this is the Little Dipper right here. This is Polaris, which is the North Star. This is the Little Dipper, so it's on the Dipper side, a little bit away from there in the sky. Again, this is stellarium, telling us where that stuff is. Right here, this is another thing we'd be able to see tonight. This is M81, it's Bode's Galaxy. This is the Big Dipper. This side is the Big Dipper, and again, this is on the Dipper side. These two stars are sort of pointing down over here. Bode's Galaxy is a big galaxy, and that's kind of cool to see it on an angle like that. This one's even more interesting, right next door. So you can see we barely moved. It's right next door to Bode's Galaxy. This is M82, the cigar galaxy. This is called an irregular galaxy. Might be two galaxies sort of interacting with each other. Kind of cool. And this is, instead of it being at an angle like the previous one was, this one is, we're looking at it what's called edge on. So we're looking at it, it's like looking at a plate instead of this way, like this from the side. This is the Whirlpool galaxy, M51. And this one's really cool, right? This one this is the one where we're looking right at the face on, they call it. So not edge on, but the other direction, right at the top of the plate or the bottom of the plate. This one here is at the end of the handle of the Big Dipper, right there. The Whirlpool galaxy. This is M13, so enough of those galaxies. What else can we see? M13 we might actually see. This is a big globular cluster. It has a lot of stars in it. It's called a globular cluster because it is shaped like a globe. And the reason that these objects are interesting, they're very old objects. Those are all very old stars in there, and they tend to be located in what's called the halo of the galaxy. So they are above or below, sometimes above or below the plane of the galaxy in a sphere that surrounds our galaxy. So they also are distant objects. And this one is not near either Dipper. This one is in the constellation Hercules. That's why it's the Hercules globular cluster. And if you know where Arcturus is, and one of our volunteers will help you find Arcturus tonight, I am sure. And Vega is another bright star in the sky that will be coming up a little bit later. And this is, if you draw a line between Arcturus, that bright star, and Vega, about halfway, it's a little bit closer to Vega, but about halfway across is the trapezoid of Hercules, and M13 lies, that globular cluster lies right along that line between those two bright stars. And you'll be able to pick that out tonight, and certainly our volunteers will help you do that if you want to learn. Celestia is Lonnie had these in his presentation, so I'm mentioning them. Celestia is a 3D modeler of the universe. So you can make sure that, I think it's the visualization. Yeah, it does say our universe. So this application does 3D modeling of the objects that are in its database. So 3D modeling of various planets, star systems, and I guess the rest of the universe. So I don't think it has the whole thing in there, but what it does have, it's an interesting tool to help you visualize space in 3D. Space.com, of course, is another very important reference that Lonnie had that I'm also mentioning. And let's just review the events for May. There's the full moon. We will see it at 9:30 tonight. The penumbral lunar eclipse happened, and we didn't get a chance to see it. The Eta Aquariid meteor shower is happening tonight, so make sure you do look up in the sky. Just don't expect necessarily a lot of meteors. And the new moon phase will happen on the 19th. And then Mercury will be at its greatest western elongation. So if you happen to be up early in the morning before the sun rises, take a look at Mercury. So those are May's events. And this is all our social media here. So Kim is about to ask we're going to have a Q&A session and ask for some questions. So thank you for letting me be Lonnie tonight, and give him a round of applause for putting that together. And this is normally his series. We hope to see him next month.
All right. Thank you so much, Paul, and thank you all for joining us. So, like Paul said, we are going to be doing a Q&A session. Before we get into that, I'm going to go over a few safety briefings because I noticed a few of you sneaking in after my first safety briefing. You thought you could get away, but you can't. So, first off, for safety briefing, when we are leaving, we are using our headlights. We do not like running people over or getting run over. So we are going to respect that. Second, if you need to use a flashlight, you shouldn't because it's a full moon night and it's quite bright, actually. And for once, I can actually see getting around, so that's a nice change. But if you are using a flashlight to get around, do keep that pointed towards the ground and not shining in people's eyes. If you need to use the bathroom, it is the porta potty in the back. To my left, your right. And we have the gift shop and museum area after the presentation, and I'll be hiding out in there for a while, avoiding the pollen. So, Q&A session, how it's going to happen is if you're here, you're going to when I call on you, you're going to raise your hand and wave it around and keep it up while I'm walking to you, just because I lose my track in the dark and I've lost my distance glasses somewhere. So that's...
You need to be mic'd so the people at home can hear you too. So that's why we're asking you so that we can come out and bring the mic to you.
Yes, because chances are if you have a question, they also might have the same question, but might be a little too shy to ask it. So I'm going to start us off with the first question of the night from our online audience, and that was, is Lonnie feeling okay?
Lonnie's feeling okay. It's a minor procedure. Obviously I don't want to get into what procedure it is or anything like that, but Lonnie's a-okay, recovering, and we hope to see him next month.
All right. So like I said, are there any questions here? Ooh, okay, I see at least one. Hold on. And here we go.
When is the next blue moon gonna be?
The next blue moon. I don't have the names of the moons memorized, so I can't tell you when the next blue moon is. So maybe you can refresh my memory. Is blue moon referring to the second full moon in a month? What is?
Yes, the blue moon is the second full when there happens to be 2 full moons in a month. It is the second one.
Yeah, I don't know. Actually, I did not look that up before I got here, so I can't tell you. But I'm sure you can look at that on. I use DAF Moon to understand what on my phone. To understand what's happening with the moon. So DAF Moon or any other moon tracking website or application will be able to answer that for you. And I apologize, I don't have that prepared for tonight, so I don't know.
Ironically, also generally local news stations also tend to cover when a blue moon is, and they get really excited about them. So chances are you'll hear about it on those, like I said, the local news, TV programs, and online. So the next online question is, can you remind us what EAA means in this setting? Because I believe it's also an acronym in aviation.
Electronically assisted astronomy. So it is sort of like snapshots as opposed to astrophotography. Astrophotography involves taking long exposures, maybe many nights of data of the same object, and then melding all that data together using various techniques and programs to do so, and coming up with a a beautiful image. EAA, the electronically assisted astronomy, is similar to astrophotography in that it's also using a camera. However, it's short exposure, quick and dirty processing that usually happens, in one program, and you can display that immediately. And so it's like the Polaroid camera of Polaroid camera of photography. EAA, electronically assisted astronomy.
All right. Next question from out here. All right. I saw a hand go up all the way back here first. Hold on.
Can there be a blue moon and a red moon on the same night?
A blue moon and a red moon. Now you're really testing my knowledge of moons. I don't even know what a red moon is, other than sometimes the moon does appear red due to atmospheric effects. During an eclipse, it would. So red moons sometimes do happen, but I don't know necessarily that there is a moon called a red moon. But someone tell me if there is. And I imagine if what I'm saying is correct about what you mean by a red moon, then that blue moon, that the second moon in a month that happened, could be a red, depending upon atmospheric effects or whether it happens to be an eclipse.
All right.
Yeah, Halley's Comet was here in '86. How could it left that much debris from that passing?
Yeah, it's a space, right? So craters and stuff disappear on this planet. All that cool stuff in the sky, in the atmosphere, disappears because we're here on Earth, and microbes and weather and other things happen. In space, that stuff doesn't happen, so it just hangs out, and it can disperse to if another object were to disturb it, but if it remains undisturbed, then it's just going to hang out there.
All right. So our next online question is, what is the difference between soil and regolith?
I don't know the chemical other than, soil does have, on Earth here, it does have organics and, living aspects to it that regolith does not. I understand that regolith, at least I've heard from some of the news about them designing the new suits, etc., the new space suits, that it is a pretty tenacious and difficult inorganic agglomeration of particles, and that they can be very sharp, and but it's pulverized rock without the organic. Just think of it, though, simply as moon soil. Just it's different from Earth because we have things happening down here that are not happening on the moon.
All right. So our next question is over here. You might have to scoot over to. Sorry, hon.
How many stars are in the sky?
All right, start counting now.
Asking the tough questions here.
All right, there. I've heard different numbers, but in our Milky Way alone, there's about 300 billion stars. 300 billion. So 1/3 of a trillion stars. Andromeda, which we can see later in the year, does have 1 trillion stars in it. So it's bigger from the number of stars point of view. So that's in those galaxies. There's maybe 200 trillion galaxies in the known universe, in the observable universe. Excuse me, maybe I might get that. Let me make sure I I think that's 2 trillion galaxies. So multiply 2 trillion by, let's call our Milky Way galaxy an average size galaxy, by 300 billion, and that's how many stars there are.
And I'm sure there's a error factor of a couple zeros
Yeah,
there.
that's not going to be an exact figure in any shape or form.
All right, so we're going to continue the Q&A session. However, I noticed Paul's mic was having trouble, so I'm going to take his mic and replace the battery. So I'm going to ask you guys for a little bit of help. Next question, you're going to kind of come up, and you and Paul are going to share a mic while I go get that battery changed, okay?
We are experiencing technical difficulties. Please stand by. Okay, anyone else have a question? Okay, is that a hand up over here? All right, I'm going to reach in.
Why is there places on the moon just like the Earth?
That's a good question. There are places on the moon that are like the Earth. For instance, they call them seas. They thought, when people first looked at the moon, they thought that those things looked like seas. But as they understood more, they realized they're not really like seas on Earth. So first we thought one thing, and then we thought another. So science progresses. As we understand things more, they can look the same, but then they become different as we understand more. Or we can find out that they're actually quite alike. So that's a good question. We can understand things that are the same that what we experience on Earth, and we can understand that some things are different than what we experience on Earth. Excellent question. Yes, sir.
When is the moon rising tonight?
9:30. 9:30 is the data that I have on when the moon's rising, and I'm supposed to be back in the camera here, so I'm going to ask people actually who have a question maybe to come up. Anyone else have a question? If you don't want to be on the camera, just tell me and I'll reach out.
When you're observing the night sky, how do you tell a planet and a star apart?
How do you tell a planet and a star apart? Well, the first thing is, remember what I mentioned about the ecliptic plane, correct? So if it's in the same area that the sun and moon travel, and it's bright, then it's probably a planet. So that's one way, but let's talk a little bit more about that, because that's a good question. Another way you can tell is that if we come up here, all right, we can all agree now, May 5th, we'll all be here again next year. So we can answer this question a little bit better, or we can observe that it's correct. All the stars will be in the same place they are right now. We'll look up, the same stars will be in the same place. What will not be in the same place? A young lady who came up here and asked the question. What do you think won't be in the same place? If we come up here May 5th and all the stars will be in the same place, what will not be in the same place? The planets, right. So the planets are, the original meaning of the word planets was wanderer. And so the ancient astronomers realized that these things do change over the course of the year, their positions, and that's another way to tell the difference between planets and stars. They move. Plus, you'll see in the telescopes tonight, they'll get to be big circles in the telescope, and stars will not.
All right, I'm going to let Paul get his headset back on now that we've replaced the battery. But I'm going to start with the next online question. And this one's a snarky one, so you're going to get a kick out of it, Paul. if you take 2 monoculars, now keep in mind those are basically small magnifying devices where there's one, so you hold it up to only one eye. And just turn the Sorry for Okay,
Okay.
testing.
Hello?
Apparently the battery caused
Hello?
Hello?
Oh, we have audio. You guys can hear that on the speaker now, right? All right.
All right. So apparently the battery caused more problems than I meant it to. So that was a fun thing. And also it was slightly alarming, so I lost my track. But the question was, if you take 2 monoculars and use them together, would they be a pair of monoculars, or would you then consider them binoculars?
Yeah. I wouldn't consider them binoculars only because holding 2 binoculars steady and having them aligned in the same direction, I think that's a really important aspect of binoculars. So I don't think holding 2 separate binoculars together could ever be considered binoculars.
I don't know, but enough duct tape could fix that.
Well, yes, you could get them affixed so they wouldn't move, but I don't think the result would be tremendous.
Right. Was there another question out here? Right.
Why can't we only why can't we only see one side of the moon and not the other?
Good question. The moon is what's called tidally locked to the Earth. The moon's actually moving away from us, so it was a lot closer, and that gravitational interaction means that the tidal nature of the moon's influence on the Earth and the Earth's influence on the moon, the solids actually flex back and forth, and it makes the moon's rotation. The moon actually does rotate, but that rotation happens to be exactly equal to the orbit of the moon around the Earth, and that's what tidally locked means. So if the moon wasn't rotating and Kim can be the Earth, then it would look like this, and we would get a chance to see all sides of the moon, right? Because me being the moon and not rotating, I'm doing this. Right? So you would actually get to see various sides of the moon, wouldn't you? But what the moon's actually doing is this. It's tidally locked and always facing the Earth. So the rotation of the moon and the orbit of the moon happen to be equal, and so we only get to see one face of the moon.
Right. I know there were several other questions. All right. Also, I really like your panda suit.
Thank you. I was wondering what the brightest star is called.
Sirius.
Can you see all the planets in the sky?
You can. You would need a telescope to see Uranus, Neptune, and Pluto. The other planets you can see with the naked eye. And obviously you can point the telescope at the ones you can see with the naked eye to see a lot more of the planet. So they're kind of cool anyway to point a telescope at. But you can see all of them, and so that maybe you can see some of the outer planets naked eye in a really dark spot, but I don't know that. Certainly the 5 Venus, Mercury, Mars, Jupiter, and Saturn, those are the most easy to see naked eye. The rest I would recommend a telescope.
So basically, anything's visible if you have the right instrumentation at the correct spot.
Right. If you have a big enough telescope, you can see everything. Well, not everything. That's not exactly true. but
Some things you don't want to see.
well,
That's why we don't explore the deep oceans.
there
They saw enough and said, "No, thank you. I want off the planet."
So we can't see all the way out into the universe. We can only see the observable universe. There are things moving away from us in the universe faster than the speed of light. We will never see them.
All right. Also, going back to a question, because one of our online viewers did the math that you requested. So it's an estimated 6 to the 23rd power number of stars in the observable universe, and that's 6 with 23 zeros after it, aka 200 sextillion is an estimate.
That's a mole of stars. Excellent.
Quite a number. But yes, I am very proud of you, Monkey, for taking the time to do that math, because I was not going to do that math. The only way I'm doing math is if it's in an Excel spreadsheet. Right. So I know there were more questions out here. Oh, back over there. Oh, put your hand down.
What was the last time Haley's comet passed?
That was, I think my slide said 85. Someone out here said 86. It's one of those. So I think my slide, though, said 85. I can, let's see if I can get there quickly.
Yeah, the fun part about this is sometimes you don't need to remember, guys, you don't need to remember all the answers. You just need to know where to find the answers.
So the answer, of course, is both, because that graphic, as you can see, started in 85 and then went to 86. So it was from the end of 85 through 86. Halley's was around Earth somewhere.
Right. I know there was another question back over here. And just a reminder, I'm kind of night blind because I stare at a device screen and light kills your night vision, even though it's a nice full moon night. So keep your hand up when you put it up. Oh, there we are.
How many dwarf planets are there, and what are their names?
Well, Ceres is one of them.
I think it's Ceres, Eris, Vesta,
Yeah.
Hesta.
Right. And there's theorized, there's the whole reason why Pluto was demoted, right, was the idea that that Pluto is also considered a dwarf planet officially now. A lot of people love Pluto, and Pluto's part of our heritage. It's one of the things that we found in the, I think it was found in the 40s. New planet found. We should be proud of that. That finding an object so far away with that the technology available at the time. So Pluto was demoted, and the reason it was demoted is because there's an actual need for that to happen, because there's, there could be hundreds of trans-Newtonian objects that are dwarf planets. So do we want to go from 9 or 8 planets to hundreds of planets? That doesn't make any sense from a categorization point of view.
Imagine taking that science test.
Imagine taking that test, right? That's
I don't know about you, but I'm getting 9% on that test then.
So, and then when we started finding planets around other stars, that became, let's call that unwieldy, that number of objects. So it could be that many dwarf planets in our solar system and, in other solar systems. So that's the whole idea behind the dwarf planet category and why Pluto was demoted. Now, there are plenty of people who still think of Pluto as a planet, and I agree with both sides. It is an important part of our history, and the categorization is problematic, so it probably needs to change So maybe we can make an exception for Pluto. Who knows how that's going to maybe they're going to debate that and come up with a solution to mix those two, to combine those things well, better. But so there is a scientific reason and a historic and a societal reason why Pluto was demoted. But there could be hundreds of dwarf planets in our solar system, and that's why Pluto was demoted.
Right. My online chat is full of fun additional facts from these questions. But the next online question was, why is stellarium often suggested as a guide for viewing things rather than celestia?
Stellarium, I don't know why stellarium is preferred over other, obviously, Google, I think Google Star Map is a pretty popular one. I have to say that for free software, stellarium is extremely powerful and has a lot of information. Plus, it's very customizable with add-ons, so it's very good. We're getting close to, we're like 5 minutes after 9. I'm
Yep.
sure people want to go see stuff. And I'm not saying, let's go to the live audience and maybe take one more question from the online.
Yep. And as far as that question about stellarium and celestia, stellarium's very ground-based. So you pick a location on Earth and you can see what's overhead. Celestia is great if you want to zoom through the solar system and the universe and like pretend you're on a spaceship.
Yeah, it's more for visualization than finding objects.
Right. So who wants to get the last question here? Right. I saw a hand shoot up right over here.
Which planet has the most moons?
I think Jupiter has a huge gravitational field, pulls in a lot of junk. I think it's over 80 moons at this point. So we can't see all of them, but we can certainly see tonight. You'll actually be we won't see Jupiter, but when you can see Jupiter in one of our telescopes, you'll be able to see the Galilean moons. That will be later in the year, but you'll see other moons. You could possibly see other moons too, depending upon their position. But usually you can see 4 Galilean moons. And like I said, I think last time I understood how many the moons they found on Jupiter, it was in the 80 range.
Right. And a full answer to one of our in-person questions about the how many dwarf planets. There are 5 recognized dwarf planets, but an estimated over 200 dwarf planets in just the Kuiper Belt. I think I said that correctly.
Yep.
Right. So with that, I'm going to spend a bit of time online answering any questions that we did not get to answer right now in text. But I want to thank you all for joining us, both here and online. We very much appreciate it. If anyone here does check us out on YouTube or Twitch, do like and subscribe. You viewers at home, also hit that like and subscribe button to let us know we're doing a good job and that you want to see more content like this. And with that, like I said, everyone have a safe night and go have fun looking at the sky.
Thank you, everyone. Good night.